Welcome to another edition of RCE. Again, this is Brock Palin. You can find us online with the complete back catalog at rce-cast.com. You can also find a link to the iTunes store where you can subscribe on your Apple products, and a link for any other podcatcher you'd possibly be interested in using in an RSS feed and all that goodness. Once again, I have Jeff Squires from Cisco Systems and one of the authors of OpenMPI. Jeff, thanks a lot for your time.
Hey, Brock, and it's that time of year again. Everybody is starting to gear up for supercomputing, and I can tell you one of the things that I'm involved with supercomputing is the student cluster competition again that you and I have been involved with before. But this year, I'm on the other side of the table. Cisco is directly sponsoring a team, the Illinois Institute of Technology, and we're going to outfit them with a bunch of Cisco servers and some of our switch gear and the low latency product that I work on. So it's actually going to be pretty cool, pretty fun stuff, even more so than usual for me.
Yeah, that's a really cool program. As you mentioned, we've been involved before. We've been judges for it twice, and we've had the competition organizers on the show, and we've actually talked to a winning team once before. And it really is a great place where these kids are getting good training, learning how to do stuff so that, basically, if you're looking to hire a cluster admin, a fresh one, these are the people you want to talk to because they get...
And developers, yeah.
Yep, and developers because they get applications, systems, everything all in one shot, specific to this industry.
All right,
okay.
Today.
So our guests today come from Oak Ridge National Lab, and we're going to be talking about ADIOS. And we have with us Scott Klasky and Norbert Podhorszki. And Scott, why don't you take a moment to introduce yourself?
Sure. Thanks. So my name's Scott Klasky. I'm a distinguished scientist here at Oak Ridge and a group leader for scientific data. So I work generally with very large or big data problems. We've designed the ADIOS framework for one part of the solution, and we do a lot of other things in my group for data management, data analysis, and visualization.
Hi, my name is Norbert Podhorszki. I'm a research scientist in Scott's group. I'm the lead developer of the ADIOS software, and I work a lot with application users who run codes at large computers, mostly at the Oak Ridge leadership facility, but also with some other users worldwide. On research-wise, I'm mostly interested in how to enable moving data from the memory of an application to other places and process it on the fly.
Cool. So I wonder, could you give us a quick intro? What is ADIOS to start off here?
Well, that's a really good question. So in the very simplest sense, just think of it as an abstraction framework for data-intensive science, or what some people call big data. So it really relies on the fact that we wanted to work with both data in transit and data at rest. So the win for us is that as we start thinking about data being objects, or say variables in a simulation or objects in an experiment, you can just view this as self-describing data being chunks. So whether we're working with something for post-processing or during an in-situ calculation, we're trying to do these things very efficient, and ADIOS works on essentially the largest systems in the world in order to achieve this.
So how did this get started? What was the driving force?
So you can call this something which is a very long-running project. I was a student in relativity at University of Texas at Austin, and when I was a PhD student, I really was trying to coalesce black holes, and I needed to sometimes write my data to the file system for post-processing, but a lot of times as I was trying to understand numerical methods, I was trying to analyze and visualize the results. So we wanted to abstract this framework. And this was done in conjunction with one of my advisors, Professor Matthew Choptwick, who's now at University of British Columbia. So we designed this system, but it was a point solution. We progressed later on through Fusion, where I worked with Professors Zihong Lin and William Tang, and they were trying a run, and this is going back approximately 15 years ago, where we had IBM SP2 at NERSC, one of the DOE resources. We were running at the time largest simulations, 1,000 processors. We wanted to analyze, visualize the data in real time. It was a large amount of data, about a terabyte of data being produced in a day. So we had to stream, process, create the workflows to do this. Then ADIOS grew further as we had larger systems coming out. So as I moved over to Oak Ridge from Princeton, what I saw was a need to really formalize this. So I worked with mainly Rutgers University and Georgia Tech, professors Manish Parashar, Carsten Schwann, and Matthew Wolf, to really formalize this and create something real. And we started to get a lot more collaborators from all over the world bring this together. So now we actually have 7 releases, and we're trying to make this something which is fully open, not just open in terms of the source, but open in terms of how people develop. So more or less delivering something which is similar to service-oriented architectures for the largest computers in the world, as well as for smaller systems.
Okay, now one thing I think we left out at this point is, what does ADIOS stand for?
The Adaptable I/O system.
So with all of this, with this long pedigree and long history and evolution over time, you said you have 7 releases. Are these 7 major releases that have, kind of created over time, major functionality improvements or new features, or is it just more adapting to the different I/O landscape over time, the different architectures and how we get data from RAM out to stable storage and things like that?
Excellent question. So pretty much I'll say all of the above. They were all major releases. I think when you start, we started out saying we're going to work with 90% of the codes. And what that meant was, if you're working with a code that was different, okay, great. We're not going to care about it right then. So we wanted to have a solution for certain codes. So we started out, we really wanted to speed out checkpoint restarts. That was a particular problem on our Lustre file system going back when the craze were first put in for leadership class computing at Oak Ridge. But then we started to expand. We wanted to be able to read data for more general analysis. We wanted to use data staging. We wanted to use, if you want to say, burst buffers, wide area network movement. We wanted to have data which was even more self-described, injecting code into the data streams, injecting workflow in the data streams. So as the technology increases, of course, as the core counts go up by orders of magnitude, we are always seeing ways to improve. There's always bug fixes. So it's a combination of new features, new bug fixes, new types of simulations or experiments which are doing things that we never thought of.
Now let me pick on 2 things you said in there because they really caught my ear in there. You said even more self-described over time. Does that mean you support new types or finer grain types or new patterns? And then the second thing that I heard was you inject code into the stream. Are you talking something like serialization and deserialization, or what does that mean?
Good questions. So we have, of course, ADIOS is a large project, many people. So I'm now talking about different research that has now gone into production, although we can't say there's that many users for some of these features. But in terms of, let's see, code. The code injection is done through 2 ways. One, we can actually inject the code for pointers to functions which can then execute routines. This was a paper that Manish Parashar and some of his collaborators and students published. So that was pointing to different codes and executing it. So both of these are more, how do we move work to data versus always moving data to work? So that was one point. Okay, so in terms of more metadata, so when we think about what's really important, I mean, we get a publication and people are talking about